A splinter of winter, fraction wonderland. We're going to add and subtract more fractions. If the first video went a little too fast, don't worry. We're going to go a little bit slower here so that you can understand what we're doing. This is also a great video to review. So we're going to use common denominators when adding and subtracting fractions. When we do that, we definitely need to persevere in problem solving, check our work, look for patterns, and if you want to, feel free to model with mathematics and use your fraction tiles as tools. Lexi used 1/3 cup of chocolate chips in her cookie recipe. Notice I did not say 1/3 cups of chocolate chips. And that's because we know from ELA that when you add an S to the ending of a word, that means that it's more than one. And when we're dealing with fractions, it's not more than one. I know that sounds strange, but that's what we're doing. And Layla used 3/4 cup of chocolate chips in her cookie recipe. What was the total amount of chocolate chips used by the girls combined? Now, when I see the word combined, I know it means I'm adding what Lexi used to what Layla used, and that should give me the total. So my equation is 1/3 plus 3/4 will equal my unknown amount, which is the total. Now, in order to add these fractions, I have to find the common denominator. Now, that's vocabulary that we've been using. Let's note that the least common multiple is often the best number to use for the common denominator. In our class, we abbreviate that the CD, like our friend. Like, yo, CD, what's going on? I need your help. Okay? So here we have the least common multiple is used for the least common denominator. So I want to make sure you understand the relationship. We find the least common multiple so that we can use that as the common denominator. That way you won't get too confused. Now, let's take a look at our denominators. We have 3 and 4. We need these to be the same number so that it's easier for us to add. So we've got to list the multiples of 3 and the multiples of 4. So let's do that over here to the left. And we don't want to do that with our highlighter. So we've got 3 and we have 4. Now the multiples are the numbers we get when we're counting by that number. So you're like, what? You remember this from 3rd grade. 3 times 1 is, and let's put a colon here so that we know we're counting by threes. So let's list the multiples, and we'll list the multiples by skip counting by threes. So we've got 3, 6, 9, 12, 15. What's next? Good. 18, 21, 24. Great. Let's stop there because we've done 1, 2, 3, let's count them. 1, 2, 3, 4, 5, 6, 7, 8 terms. So let's do 8 terms for the next one. Let's count by fours. We've got 4, 8, 12, 16. What comes next? Good. 20, 24, 28, 32. Okay? Now, let's look at the numbers or the multiples because these are called multiples. Let's look at the multiples that these two numbers have in common. Do you see what I see? I bet you do. So we see that they have 12 in common, and they also have 24 in common. When we say in common, let's write common multiples, and we're going to highlight the common multiples in green. That way we know that all of these numbers are multiples, but the ones that are in common are the ones that are green. 12 and 24 are the multiples that these two numbers both share, but we want to look for the least common multiple. So let's highlight the least common multiple in pink. Which number or which multiple is the least or the smallest number? You're right. Uh-oh, I made it disappear. The number is 12. So that's going to be our common denominator. So let's use the number 12 as our denominator. Now, after we use the number 12, we've got to take another step. So let's go to step 2. Now we're going to rewrite the expression using equivalent fractions that have common denominators. What? Let's go back. What is our expression? 1/3 plus 3/4. So let's write 1/3, and we're going to write it this way, plus 3/4. That's what we want to do. And then we see here that our common denominator, the denominator we're going to use, the denominator that these two have in common, is going to be 12. Our common denominator is 12. Now we have to ask ourselves the question, what do I do next? It's very easy. You're going to ask yourself, what do I do next? And the answer to that question is, how did you get from 4 to 12? You're right. You multiplied by 3. And whatever you do to the denominator, you have to do to the numerator. What is 3 times 3? You're right. It is 9. Same in the next one. What did I do to get from 3 to 12? You're right. You multiplied by 4. And whatever you do to the denominator, you must do to the numerator. 1 times 4 is 4. What you'll notice is that you have listed here equivalent fractions. 3/4 is equal to 9/12, and 1/3 is equal to 4/12. But what we've done is now we have common denominators, similar denominators, which will make it much easier for us to add. So let's rewrite what we have, or you could just go ahead and solve. 4, remember our operation sign is to add. 4 plus 9 is, you're right, 13. So the answer is 13/12. Now, just a note, if 12/12 is 1, then 13/12 is 1 whole with 1/12 left over, right? Because 12/12 is 1. So then 13/12 is 1 whole with 1/12 left over. So we can write this as 13/12 or 1 and 1/12. Oh, we already solved the problem on the other page. So if we were to rewrite the expression so that we could evaluate it, we would have written 9/12 plus 4/12 equals 13/12. And this 13/12 is already written in the simplest form because there are no factors of 13 and 12. What does that mean? Let's say we had a completely different one and we had like 4/8. Well, we can simplify 4/8 by dividing the numerator by 2 and the denominator by 2 so that the simplest form, actually, it would be 4. Even easier. We would divide the numerator by 4 and the denominator by 4. And so 4/8 in the simplest terms is 1/2. 3/6 in the simplest terms is 1/2. 4/12 in its simplest terms is 1/3. Does that make sense? 13/12 is already in its simplest form. Here's another problem. Grace and Matthew were sharing a bag of M&Ms. How many M&Ms are yellow or orange? So let's see. How many are yellow? Well, first we need to know how many there are in all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is our denominator. So we've got to add yellow and orange. How many yellows are there? 4. How many oranges? 2. Now, these two have a common denominator, so the total is 6/13. And because we have a prime number here, this is a fraction written in the simplest form. Let's try another one. Olivia and Gavin have personal quiches. Ooh, Olivia ate 3/5 of her quiche. Gavin ate 5/8 of his quiche. How much more of the quiche did Gavin eat than Olivia? Ooh. Pause the video and try this problem. Okay, take a moment and check your answers. You'll see here that we have Gavin and Olivia and their amounts. Notice our equation here. We need to subtract Olivia from Gavin so that we can find the difference. And the difference is 1/40. So Gavin ate just a little amount, 1/40 more of his quiche than Olivia did. It's a very small amount more. And you can see how we found the equivalent fractions to use here because we found the common denominator by using the least common multiple here. Thanks for watching.